Welcome to the lecture 3 on module 5 of ARM microcontroller and embedded systems. So in the previous lecture we discussed about the real-time kernel, the services provided by real-time kernel, how it is different from the general purpose kernel, then the types of real-time systems. Now today we shall discuss about tasks, processes and threads. So in the first lecture itself we had discussed about what is a process, what is a program and what is a thread. So program is a set of instructions and associated data that resides on the disk. So that resides on the secondary memory. So until and unless you run the program, it will not become a process. So whenever you start to run a program, so a program can be an executable file or it can be a Python script. So as soon as you start to run it, it will become a process. So I had given an example. So program is like a human being, process is like an organ. So a program, it is a human being has various organs, nothing but process. So a program can have multiple processes. And then a thread is like a cell in the organ. So in one organ, that is in one process, there can be multiple cells or multiple threads. So what is the thread? So thread is the smallest unit of execution, similar to a cell. So that is what is the example. So a thread simply executes instructions serially. So it is serial execution of instructions. So to brief, so this is the diagram as shown. So a program can have multiple processes and a process can have multiple threads also. So I had also opened the task manager and I had shown you how many processes are running currently. Right, so again, once again I'll show you. So I'll open the task manager. So just press Alt Control Delete. So you'll get the task manager. Just go to the task manager. So in this task manager, so if you go to details, okay, so you can see the number of processes that are already running. If you go to services, so services which are running. So PID, as I told, this is a process ID. It is a unique number given to each process that is executing. Okay, so if you go to performance and if you go to open resource monitor, so now here it will show you. So what is the process? What is the process? So this process has 8 threads. Okay, so each process has 8 threads. So it is a program. So it is a process corresponding to the program. So there is a Skype program which is for that. This is the process, and there are 4 threads for that. Okay. You can see I'm using the screen recorder named debut. So it is running. So this is the process, and it is having 16 threads. Okay, so these are the threads. So we shall go back to discussing process threads and tasks. So in operating system, so a task is nothing but the program in execution. So process and task, they are used interchangeably. Remember, so task and process both mean the same. They are used interchangeably, and the related information maintained by operating system for the program. So within our operating system, task and a process is same. Task is also known as a job. So process or task is also known as a job in the operating system context. So a program or part of it in execution is called process. And so task and process, so you can see the term task, job and process refer to the same entity and they are used interchangeably. So all the three mean the same. So a process requires various system resources. So which are the system resources? So again, if I go back to the system resources means can be primary memory, secondary memory, CPU, peripherals, IO devices. Okay, so the hardware like monitor, speaker, camera, all these come under resources. Yeah. So a process requires system resources like CPU for executing a process. memory for storing the code and associated variables, as well as IO device. So these are all required for a process. So as soon as a process is created, it will be allocated with some memory to store the code and the variables. It will be allocated CPU on based on scheduling techniques. We will discuss them later. So a process will not have access to CPU always. It will be only given a fraction of the time to utilize the CPU, because CPU is a limited resource. It is not like memory, so wherein there is a plenty of memory, so all the processors can have hold of memory. But CPU, okay, so CPU is you can say in one system it can be one or two CPUs. That's all. So that two CPUs should be shared with hundreds of processors. In that case, the process will not have access to CPU always. Right? The structure of process. So how the process looks like. Concept of process leads to concurrent execution. That is pseudo parallelism. So pseudo means false. So it is false parallelism. So it looks like parallelism, but it is not parallelism. It is again sequential execution only. Just imagine. So there is a one chair and there are two persons waiting to sit on that chair. Okay. So what will happen? So at a time, only one person can sit in the chair. The other person has to wait. So after this person moves out of the chair, so that the other person will sit in the chair. So this is what is serial execution. That is what will happen in any system. But this sitting and moving out of the chair will be so fast. Means the user will be under illusion that two persons are utilizing the chair simultaneously. So they'll sit and they'll move out. They'll sit and move out. So this sitting and move out of the chair will be very fast. So that person, the user will think that both the persons are sitting in the chair simultaneously. So, but that is not possible. So concurrent execution, what will happen is it will improve the efficient utilization or improve the efficiency of CPU and other system resources. So the system resources will not be kept idle. Okay. So example. So again, I'll go for the chair. Example. So two persons are sitting or want to sit on a chair. So there is only one chair. So one person is sitting and other person is waiting for the chair. So let's say the other person has some other job to do. So he will go off. So this person who sits in the chair, so he will finish off his term and he will stand. So in this case, the chair is empty. So the chair is not utilized because the other person who was supposed to sit on the chair is not available. He has gone for doing some other work. Okay, so in the meanwhile, the chair is empty, so it is not utilized. So after some time, again the first person will sit in the chair. So now it is utilized, and again after his turn, he will get up and leave the chair. So they are at this particular point, again the CPU is unutilized. Sorry, or the chair is unutilized. So that is what. So but whenever there are multiple processes, so if there are more than two processes, if one process or one person is having some other work to do, so some other person will come and utilize the chair. So like that. So that is what is efficient utilization. See, efficient utilization for resource means it should not be kept idle anytime. It should be utilized for some job, so for doing some job. So concurrent execution is achieved through CPU sharing. So that CPU, I gave an example of a sharing of CPU. So the process mimics the processor in its properties. Okay, because a process will have the position of CPU, it will have the position of memory, and it will have the position of IO, which is nothing but a process. So that is why it mimics. Mimics means it will you know about mimicry, right? So some person will mimic some other person like that. So when a process gets its turn, its register and memory program counter registers become mapped to physical registers of CPU. So now we will see what does a process contain. So this is a process. Okay. So a process will have its own stack memory. Okay. So it will have its own working registers. It will have its own status registers, and it will have its own program count. So a process. So let's say there are 100 processes. So each process will have these whatever the content. So it will have its own stack, it will have its own working registers, it will have its own status registers, and it will have its own program code. So this is what a process will look like. Okay. So next we'll talk about memory organization of a process. So the memory occupied by a process is segregated into three regions. So one is stack, one is data, and one more is code. So each process will have three you can say parts of memory. So you can segregate the parts, the memory into three parts: stack, data, and code. So they are self-explanatory. So these parts. Okay. So stack holds all temporary data such as variables local to the process. So data holds all the global data, and code contains the program or instructions that need to be executed. So they are self-explanatory. So the stack memory usually starts at the highest memory address from the memory area allocated for the process. So this we have this we have seen in ARM microcontroller. So wherein the stack starts at the top and it will grow downwards. So this is what is the diagram. You can see stack memory grows downwards. It will start with the highest memory and it will go on growing downwards. For data memory, it grows upwards. So it will start with a lower memory address and it will grow towards a higher memory address. You can see the data stack memory. This is the data memory and this is the code memory. So this memory organization of process. So remember there are three parts of the memory in process. So next, process states and state transitions. This you might have already studied in operating system basics, uh, wherein there is a cycle, process cycle, right, and various state transitions. So the creation of a process to its termination. So from creation to its termination, a process will have multiple states. Okay? It is not only single step operation, it's a multiple step operation and there are multiple states in which a process can be present. Okay, a process can be present in multiple states. Okay, so it is just like uh, you order a product on some online website, let's say it's Flipkart. So there are various states there. First thing is order accepted, that is the first state. Second state is order being processed, that is the second state. So next order packed, so that is the third state. Then order is shipped, that is the fourth state. Then order is out for delivery, so that may be the fifth state. So that is what. So in the process of procuring an item from through online, so these are the states. Like that, the process from its initiation to termination will have multiple states. So hope you are getting the example, right? So the process traverses through a series of state transitions. As I told, it can be order accepted, order processing, order packed, like that. Okay. So during this transition from the newly created state to terminated state. So first state will be created state and the last state is terminated state. So as I told you, have to map the embedded concepts to real world examples, then only you can remember. The cycle through which the process changes its state from newly created or to execution completed is known as process life cycle. So it is life cycle. So it is from newly created to execution completed. So it will traverse through various states. So this is known as process life cycle. So the various states through which the process traverses indicates the current status of the process with respect to time and also provides information on what it is allowed to do next. So this is the created. Okay, so we shall see what is created state. So then it is ready. So ready means it is waiting for this chance to get the CPU. Then once it gets the CPU, it is in running state. So from running state, either it can be preempted and it will go back to ready state. So this ready state will have a queue known as ready queue. So there all the processes which are waiting for getting the CPU to continue execution will be there in this queue. So from the running state, it can go back to ready state if it is preempted, because each process cannot be given the CPU for infinite time. It will be for a short duration of time. So once it it uses CPU, it has to go back to ready state, or it can go back to blocked state. So when it goes to block state means whenever it is waiting for an event to take place. Suppose the process wants a key press. So unless the user presses a key, suppose it is an ATM machine, so you have to enter the pin. So unless you enter the pin, which is nothing but key press, the process will not continue. It cannot go to the next. So that is when it will go to blocked state. It will not go to ready state, it will go to blocked state. So once the key is pressed or pin is entered, so then it will be moved to ready state. Remember, in ready state only there are processes which are waiting only for CPU, only for CPU, but not other resources. So if it has all other resources that it wants to run and it only needs the CPU, then only it will be in ready state. So then complete. So now we'll go on to each state. So created state. So the state at which process is being created is referred to as created. So the process is just created. So the operating system recognizes process in created state. It recognizes the process which is in created state, but it is not given access to any system resources. So a process which is in created state has no access to any resources. Remember, ready state. So state where process is incepted into the memory and awaiting the processor time for execution. So already the process is incepted into the memory, that is it is given the memory as well as any other resources it wants to execute, but it is waiting for processor time, that is it is waiting for the CPU. Okay, so it is waiting only for the CPU. So that type of state is known as ready state. So at this state process is placed in ready list queue maintained by OS as that. So there will be a queue which will be maintained, which will consist of all the processes which are ready to execute, but they only require the CPU. That's all. So then is running state. The state wherein the source code instructions corresponding to process is being executed. So this is the next state wherein it is a state where the source code, that is the instructions corresponding to a process, are being executed. So they are being executed means the process is given the CPU. So unless it is given the CPU, it cannot execute because it cannot do the processing or it cannot do the operations like addition, subtraction, multiplication, whatever, unless CPU is given, because CPU will have the ALU. Fine. So that is what is running state. So running state is the state at which the process execution happens. Fine. So next is the blocked state. So blocked or wait state, so the name itself indicates, so the process is waiting for some resource, okay, or some IO event to take place. See, the state where running process is temporarily suspended. So whenever the process is running, it is temporarily suspended. So a ready process cannot be suspended temporarily. Only the running process can be suspended. So it is temporary suspension from execution and does not have immediate access to resources. So a process in waiting state or block state will not have immediate access to resources. So the block state might be invoked by various conditions, like the process enters wait state for an event to occur, like as I told, like key press. Okay, key press is an event, or waiting for getting access to a shared resource. So let's say it wants to access the printer, but currently the printer is being accessed by some other process. So till the printer is available, this particular process which wants the printer will wait in blocked state. So once the printer is available, immediately this process in the block state will move to ready state, not running state. It can only move to ready state. So next completed state is state where the process completes its execution. So next we will move on to threads. So as I told, thread is the basic unit of execution. So that is what primitive state, primitive that can execute the code. Primitive means basic unit. So it is sequential flow of control within the process. So that is, it executes one instruction after the next. So sorry, one instruction after the other, next one after the other. So thread is also known as lightweight process. So the other name. So a process can have multiple threads. So we saw that in the task manager in the starting of the video. So different threads which are part of process share the same address space, meaning they share the data memory, code memory, and heap memory. So what do you mean by this? Since a process can have multiple threads, so all these threads will share the same memory that is allocated to the process. So whatever the memory that is allocated to the process, that memory itself will be shared by all the threads of that process. Okay. So threads maintain their own thread status. So again, so threads will maintain their own status, means they will have separate registers, they will have separate program counter, and they will have their separate stack also. Okay. So concept of multi-threading. So multi-threading means more than one thread. It's more than one thread for a process. The process in embedded application may be complex or lengthy one. Okay, so a process or a program can be very lengthy one, and it may contain various sub operations like getting input from I/O devices connected to the processor, performing some internal calculation, updating some I/O, all these. So all these are included in a process. Okay. So if all subfunctions of the task are executed in sequence, that is one after the other. So that is first get the input from I/O device, then perform some internal calculation, and then update the I/O device. These are performed sequentially, one after the other. CPU utilization may not be efficient. Okay. So why CPU utilization may not be efficient? So since you are doing one after the other, so let's say first we'll start getting input from I/O device. Okay, so it will start to get the input from I/O device, but the I/O device is busy with some other process. So this uh, task of getting the input from I/O device has to wait, or it will enter the blocked state. So since it will enter the blocked state, it cannot access the CPU. And let's say the CPU is free. So even though the CPU is free, this task of getting I/O device cannot make use of CPU because it is blocked. Okay, because it wants the access of a keyboard which is not available. So in that case, the CPU is free. So which is not efficient utilization. As I told, you call it efficient if you utilize the hardware all the time without keeping it idle. So that is what. So CPU utilization may not be efficient. So that is what is explained. So instead of that, what we will do is we'll split the process into multiple tasks. Okay, so we'll not do it sequentially, we'll do it parallelly. So this will, the process of getting the input from I/O device will be handled by a separate task. The process of calculation will be done by separate task, and the process of updating some I/Os will be done by separate task. So now this process, instead of having only one task of doing all these three, so it will have three tasks. So one, this is the first task, this is the second one, this is the third. Okay, so it is just like here I have quoted an example: shopping by one person versus shopping by multiple persons by segregating the shopping list. So what do you mean by this? Let's say I'll give an example. Suppose for your house you have to procure, let's say, milk, then you have to procure some ration, then you have to procure some vegetables, okay, and then you have to procure some fruits. So totally there are four jobs you have to do. Fine. So start with that is procuring milk, then ration, then some fruits, and then vegetables. Okay, four. So if one person has to do all these four things, what will happen? So first you'll, so let's say you'll start with time 0. Okay, so I'll explain this. So he will start with time 0. So let's say this is 0. So I'm talking about let's say minutes. This is the 0th minute wherein the person will start his job. So what is his job? First you have to procure some milk. So from 0 minutes, let's say, from your house, it will take 10 minutes to go to a shop and procure milk. Okay. Then after procuring milk, let's say it will take another 15 minutes to go and to procure the ration. So I'm talking about the commute time as well as the time required to procure ration. So 10 plus 15. Okay, so how much? 25. So actually this is 25. So from here to here it is 10 minutes. So from here to here it is 15 minutes. Totally 25 minutes of time has been elapsed. So now from after procuring ration, let's say it will take another 20 minutes, okay, for him to go and fetch or to go and procure the vegetable. So it is 25 plus 20, 45. So totally it is now 45 minutes since he has left the house. Okay, so he has procured the vegetable. So the last thing is fruits. Let's say he requires again 15 minutes to go and procure the fruits. Okay, so how much? 45 plus 50, it is 15 plus 60. So totally it requires 1 hour for one person. I'm talking about only one person to do all these jobs. Okay, so it will take 60 minutes, 1 hour. So, but the same thing, if the what we do is if we segregate it and if we have multiple persons to do the job, it is simple and the time consumed will be less. So how the time consumed is less? I'll give the example. So again, I'll start with the 0th minute, and let's say, so now since we have to perform 4 tasks, that is to get milk, ration, vegetable and fruits. So let's say the list is segregated and there are 4 persons to do job. Okay, so then what will happen? So one person will go and fetch milk. Okay, so he will take 10 minutes. So this is the person 1. Okay, so P1. So this is P1, or let's say T1. I'll mark it as T1. So one more person at the same time he will also leave the house and he will go and purchase, let's say how much? Let's say he will purchase the ration. So how much time is required? 15 minutes is required to purchase the ration. So let's say I'll mark this as T2. So next person at the same time, so leaves the house and he will go and purchase the vegetables. So it will take 20 minutes. And one more person, he will leave the house at the same time and he will go and purchase, let's say, fruits. So it will take 15 minutes. So all these 4 persons, they start simultaneously at 0 and they will go and procure and they will come back. So then what is the time required now? So we have to consider the maximum time, 20 minutes. So within 20 minutes, whatever you need or the 4 items will be coming and sitting in your house. So you need not spend 60 minutes. You can do all these jobs in 20 minutes because you have multiple processes or multiple tasks. So this is T3 and this is T4. So this is the advantage of having multiple tasks. So they will do the operation simultaneously so that the time is reduced as well as the resources are utilized efficiently. Hope you got the concept. Okay. So now, so instead of single execution, whole process, the task is split into different threads. So as I gave the example, thread 1, 2, 3, and 4, carrying out different sub functionalities. So CPU can be efficiently utilized, and the thread corresponding to the IO operation enters the wait state. Another thread can use the CPU. So this leads to more speedy execution, as I told. So you need not spend 60 minutes. So 20 minutes is sufficient. So what multi-threading will do is better memory utilization. So multiple threads of same process share the address space of the data memory. This also reduces the complexity of the inter-thread communication. So since all are in the same memory or sharing the memory, so they can communicate very easily with each other. And the process of splitting into different threads. So when one thread enters wait state, the CPU can still be utilized by other threads. So example is, let's say thread 4 or the person 4 where he was went to procure vegetables or fruits. Let's say he falls down there somewhere, okay, and he is not able to come back. So in the meanwhile, since he is only went to procure fruits, the other the persons can procure the things they want. Okay, so only thing that will be left is these fruits, but the other things will be procured, the milk, the ration and the vegetable. So that will not be affected. So CPU is engaged all the time. Now we can see the diagram here. So this diagram shows, the entire circle shows the process. So inside the process, what will be there? There will be code memory and there will be data memory corresponding to the process. And same memory will be shared by three different threads. So you can see this is thread 1, 2 and 3. There are three threads within this process. Okay, so a process can have multiple threads and they are sharing the same memory. Okay. So then there is a case study, or can say a simple example of POSIX thread. So POSIX is an operating system. So what is the name? Portable Operating System Interface. So that is what is POSIX stands for. Okay, so it is a OS. So we'll discuss a simple example of how to create threads in this operating system and how to uh, uh, block the thread. Okay, if time is required, how to block the thread. So a POSIX standard library for thread creation and management is known as pthreads. So it is a library just like uh, conio.h. Okay, so stdio.h, math.h. So all these are libraries, right? In C programming or C++. So like that. So pthreads is a library for the OS POSIX. Okay. Pthreads library defines a set of POSIX thread creation and management function in C language. So there is an example here. So int pthread underscore create. So this is a command to create a new thread. Okay, so this function is available where it is available in this library pthreads. It will create a thread, okay, with the name. So the thread that is created, the new thread name is pthread underscore t. Okay, so this is the new thread that will be created and it will be given an ID. So as I told, as it's shown in the task management, each thread will be given an ID, a number, a different number or a unique number, and then some attributes for that. Okay, so then start function, then argument. So these are the things you have to pass to this new thread you are creating. Okay, so you have to pass a start function pointer and you have to pass some arguments. Okay, so this is how you create a thread in POSIX. You have to remember this syntax, no other way. You have to just remember. So what it will do, create a new thread for running the function start function. So this thread that you create, what is the name? Pthread underscore t. So it will start to run which function? Start function. So the name of the function is start function. So this thread, you can say it is under the process start function. Okay. So, so there is a typo here. So here pthread underscore t is the handle to newly created thread and pthread underscore attribute underscore t, that is this one. Okay. This one is the data type holding the thread attribute. So this is a data type. Okay. So start function. So start function is the function the thread is going to execute. So this is a function or some code that this newly created thread has to execute. And the arguments is arguments for start function. So these arguments are for the start function. So argument means some variables that you pass so that that function can work. Right? So on successful creation of this newly created thread, so a TCB will be allocated to this new thread. So TCB means task control block. So we shall discuss in detail what is a TCB later. So just remember that TCB is nothing but it's a data structure which will have all the data corresponding to a thread. Okay. So corresponds to newly thread variable. So pthread and new thread ID. So each thread will have ID. So next function that we will use is pthread join. So pthread join. So again you are using pthread underscore t that you have just created above using the function pthread create. So you're joining a new thread to the available thread. So pthread underscore t is the available thread. You are joining a new thread to it. So what will happen if you join? So this blocks the current thread. Blocks means the previous thread was pthread underscore t, so that will be blocked. So it will be moved to blocked state. So remember that process cycle. So now it will be moved to the blocked state and it will remain in the blocked state until completion of the thread pointed by it, which is the thread new thread. So now there are two threads, okay, p thread underscore t and new underscore thread. So this p thread underscore t has to wait, or it has to be in blocked state until this new thread completes its operation. So until it completes, p thread underscore t cannot come out of the blocked state. So that is what it will do. Okay, so and remember all the thread calls, that is calls means this p thread underscore join and which is it p thread underscore create. So uh, all these return an integer. Okay, so it will return an integer. So after the completion of the function, they will return an integer. So if that integer is 0, it indicates successful completion of the task. So if it doesn't return 0, let's say it returns -1, then that job is not completed properly. Okay. Then is so there is an example. So write multi-thread application. So there are multiple threads to print hello I am in main thread from main thread and hello I am in new thread 5 times each using pthread create and pthread join. Okay, so whatever the functions that we just discussed. So what is this? This is the library. It will consist of the functions required for creating new thread and joining new threads. Fine. So next stdlib and then std.io, stdio.h. So all these are header files. So then you are creating a function. So to print I am in new thread. So star new thread means star means a pointer. So what it will do is it will print hello I am in new thread. How many times? 5 times, because that is what is required. Okay. So each time it prints hello I am in a new thread, so it will have some delay. So this is the software delay. So if you remember the lab, so this is how we generated the delays in stepper motor and DC motor. So next we'll come to the main thread. So it has created a TCB. So what is TCB? Task control block, because each thread should have a TCB because it will have all the information regarding it. So now we'll create a P thread create. So we'll try to create a P thread, and what is the name of the thread? TCB. Okay, so you are passing null new thread null. So what do you mean by this? So if you go back to the syntax now, so syntax for creating new thread. So first will come, what is this? First what will come? The name of the thread. So that has come. So next what will come? Constant p thread. So some attribute you have to pass. So this is null. So you are passing no attribute, no variable. So the third parameter is the name of the function for which you are writing this, or you are creating this thread. So there the name of the function was, what is the name of the function? So the name of the function new thread. So for new thread you are creating you are creating new thread. So this is the let's say what you can say the function for which you are creating a thread. So to execute this function, the thread will start to execute. And the last one is null. So that is no other extra parameters are passed. So you have to remember the syntax. There are uh, what is this? 4 parts. So this is the first part, the name of the new thread you are trying to create. This is the, what is this? Some attribute if you want to pass to this new thread. So next the third part is the name of the function for which you are creating the new thread, and the last one is the arguments that you want to pass to the new thread. Okay, so there are 4 parts. So that is what, those are the 4 parts that are used here while creating the new thread. So what is this new thread? It is the function. So this function you are creating a new thread. What is the name of that? TCB. That is the name of the thread you are creating. So once you create the new thread, okay, once you create the new thread, you have to check whether the thread creation was successful. So how will you check whether the thread creation was successful? So you have to check the return value. Okay, so you have to check the return value. If the value return is 0, that it means it is a success. If the value is non-negative now, sorry, it is not 0, then this thread creation was unsuccessful. That is what is checked here using if. So if this is not successful, then print error in creating new thread, return -1. So if this new thread is not created successfully, you have to return -1 and print error in creating thread. So if it is not successful, so if it is successful, so don't do anything. So if it is successful, what you have to do? You have to print, or you have to start executing TCP. So what if you start executing TCP? What it will do? It will print hello, I am in new thread 5 times. So because that is what is the function. Once this is printed 5 times, next it will go to this for loop. So what it will do, this for loop, it will print I am in main thread. Again, how many times? 5 times. So as soon as you create the TCP or the thread for the function, what is the function? A new thread. So it will start executing and it will print I am in new thread 5 times. So after this is completed, it will go to this for loop, okay, and it will start to execute this, that is print I am in main thread 5 times. Again after that, it delay. Okay. So next, so you can also use join. So why you are using join? So that you can block a particular thread or a process if there are multiple threads. So next, this thread versus process. Thread is single unit of execution and is part of a process. This can be asked. Program in execution. So what is a process? It is program in execution and contains one or more threads. So next, a thread does not have its own data memory and heap memory. So that is huge. We just saw that because a thread will have the memory shared with the process. So whatever the process has, same memory the thread also has. So process has its own memory, data memory, stack memory. So next, a thread cannot live independently. It lives within the process that we saw. Okay. So a process contains at least one thread. So next, there can be multiple threads in a process. So the first thread calls the main function and occupies the start of the stack memory. The threads within a process share the code, data, and heap memory. Each thread holds separate memory area for stack, but it is shared the process. So threads are very inexpensive. Processes are very expensive to create. Involves OS overhead. Context switching is inexpensive. Context switching is complex. You have to remember this difference. It can be asked for 4 or 5 marks. Differentiate between a thread and a process. So if a thread expires, the stack is reclaimed by the process. So if the process expires or dies, the resources are reclaimed by the OS. Okay. So I had given the example of a human being, organ, and the cell. Okay, so same concept you have to remember. So this is the end of lecture 4. We shall discuss about multiprocessing and multitasking in the next class. So this is the end of lecture 3. Okay, so we'll discuss about multiprocessing and multitasking in the lecture 4. Thank you.